This is the 16th video of the series Business Forecasting, and we were discussing the Box-Jenkins ARIMA method, and this is the second video of the ARIMA methodology. That means in part 1 we discussed the introduction, and now in part 2 we are going to discuss the methodology. As I have already told you earlier, I have divided this ARIMA technique into three parts. In the first part, we have discussed introduction. This is for methodology. And in the last part, that is part 3, we are going to solve a problem. That means we will implement the methodology. Okay, so in methodology, there are basically 4 steps. So the first step is checking the stationarity of the data. That means whether the data is stationary or not. So how to check that? We will check that using autocorrelation. So autocorrelation, I have already discussed autocorrelation in video number 2 of this particular series. If you have not seen that video, so please go to the I button given here and watch that video. So you will get to know what is autocorrelation. And then also I would suggest that if you have not seen the part 1 of this ARIMA series, then first complete the part 1, then come to here once again. So now you see here the stationarity means you have to understand these two terminology. One is dying out and another one is cut off. What do you mean by die out? Die out means the autocorrelation columns, that means these columns will reduce gradually. That means not suddenly. So see here, this is the first column, this is the second column. Second column is little bit lower than the first one. Third one is little bit lower than the second one, and so on. And therefore, this is dying out. This process is called die out. And what is cut off? Cut off means just initial 1 or 2 will be significant, and after that all are insignificant. By the way, I must tell you that when you see any line that is coming in between these two control limits, that means it is 0. So it is showing some value, but that is not significantly different from 0. So even if you see a column here, it is not a significant value, significantly different from 0. So if it is within this control limit, you will assume that it is 0. So therefore, in this kind of diagram, only the first 1 or 2 columns are significant, and after that all are 0. So this is called cutoff. So if you see this cutoff type of behavior, that is called stationary data. And if you see dying out behavior, that means gradually decreasing, it is then a non-stationary data. And if you see this type of behavior, that means all are 0. All the columns, all the autocorrelation lagged autocorrelation values are not significantly different from 0. So that is a white noise behavior. This is not required for this ARIMA purpose here. We just need to focus on these two. That means stationary or non-stationary. So first of all, you have to check this. So just to illustrate once again, how to check this one? First of all, you will take out the autocorrelation report, ACF. Then you will see whether the data is stationary or not. If the data is stationary, then you will go for step 2. Remember, this is step 1 that is going on. So the next step is step 2. If the data is stationary, then only you can go to step 2. But what if it is not stationary? If it is not stationary, then we will take a difference. How to take a difference, I will tell you. Then again, we will take out the autocorrelation function and check the stationarity. If still it is not stationary data, then again we will take the difference. So this will continue as a loop until the data is stationary. So how to do that? For example, this is the data. Suppose this is the original data, y1, y2, y3, y4, and so on. So suppose you check the autocorrelation of this column, and if you are finding that the stationary is already stationary, then you don't have to do anything, you just proceed for step 2. But suppose you are finding that the data is non-stationary, that means trending data. By the way, I should again mention here that by stationary we mean that the data is like this. Stationary means there is no trend, and non-stationary means the data is trending like this or like this. So if the data is stationary, then first of all you have to perform the, sorry, if it is non-stationary, that means trending data, then you take the first difference. How to take the first difference? Just subtract y1 from y2, then y2 from y3, and so on. So this is the first difference. Then once you have found the first difference, this is d is equal to 0, d is for difference, this is d is equal to 1. So check the autocorrelation of this particular column and decide whether it is stationary or not based on the cutoff or die out behavior. So if it is stationary, then go to step 2. But suppose if it is still not stationary, then go for the second difference. That means this is d is equal to 2. How to calculate the second difference? Simply this minus this. So y3 minus y2 minus y1. In this way, second difference will be calculated. So once you calculated this, so go for the autocorrelation and check the stationarity. If the data is stationary, then go to step 2. If it is not stationary, then you have to take another difference like this. Most of the cases, a single difference is sufficient enough to conclude stationarity. Otherwise, in some cases, like 10% cases, you have to take the second difference. It is very rare that you should go for a third difference. So that's it. That is the end of step 1, the check of stationarity. So once this is done, you going to step 2. So what is step 2? In step 2, we have to see the behavior. What does that mean? That means, first of all, you have to take the autocorrelation function. You see the autocorrelation report you have already taken out in step 1. In addition to this, you have to take out the partial autocorrelation function. Basically, all these are output of the software. You don't have to do anything. So using the software, you are taking out 2 reports. One is ACF, that is already taken out in step 1, and now PACF. What is PACF and how it is calculated? I will tell you when we will discuss the implementation method. It is not so important right now. So basically 2 reports will be taken out. One is ACF, another one is PACF. Remember, we are only discussing the methodology step by step. We will discuss the 4 steps here theoretically, completely theoretically, and then we will close this video. In the next video, we will see how to implement these 4 steps with the actual data. Okay, so you got this ACF and PACF reports. Then you check. Suppose you get the dying out behavior in ACF and cutoff behavior in PACF, then it is an AR model. A cutoff model in ACF and dying out behavior in PACF means it is a MA model. And if it is ARP, then the cutoff will be at the pth lag. And if it is MAQ, then the cutoff will be in qth lag. Remember, the situation is exactly opposite. In case of AR models, you get the dying out behavior in case of ACF and cutoff behavior in case of PACF. And in case of MA model, you get the cutoff behavior in ACF while the dying out behavior in PACF. So remember this. And if it is an ARMA model, ARMA PQ, then in that case, in case of ACF and PACF, you get the dying out behavior. So again, remember what is dying out? Dying out means your ACF functions are reducing like this. The ACF values are reducing like this. So this is lag 1, lag 2, lag 3, and so on. So ACF is like this. PACF is like, the graph is like same. And this is called die out. This is your dying out. And what is cutoff? Cutoff means the first one or two are significant, then suddenly it is zero. This is first leg, this is second leg, and so on. So the first two or first one is significant, and then all are zero. So this is a cutoff behavior. So if it is an MA model, then this cutoff behavior will be found in ACF graph, and this dying out will be found in PACF graph. And for AR model, this is the completely reverse situation. And again, I am saying you don't have to calculate anything here. ACF and PACF very easily will be taken out from the software. So in case of ARIMA models, you don't have to do anything manually. So let us see few illustrations here. So this is the summary of the flowchart that we have discussed in the last slide. That means this is the ACF and PACF. This is MAQ, ARQ, and what will be the behavior. So in case of MAQ, cutoff in ACF and die out in PACF. In case of ARP, die out in ACF and cutoff in PACF. And in case of ARMA, both ACF and PACF are dying out. Okay, so suppose you take out the report, and in case of ACF, you are seeing the cutoff is after the first flag and the PACF is dying out. So what will be the conclusion? Conclusion is MA1. See, the cutoff is in ASCF. ACF is cutoff and in first lag. So that means it is a MA1 model. If ACF is die out and PACF is cutoff at the first lag, then it is an AR model of order 1. See, cutoff in pth lag. So here first lag, this is ARP model, this is AR1, and suppose both are dying out, you know this is ARMA 1-1. But suppose something contradictory happens, for example, cutoff in first lag and cutoff in first lag in both ACF and PACF. See, we have not discussed this here. Either we are discussing both dying outs or die out cutoff or cutoff die out, but both cutoffs we have not discussed. So if such situation arises when you find that there is a contradiction based on this table, so it is better to take both the alternatives. For example, you take MA1 or AR1. That means ARMA 01 and ARMA 10. So just to tell you, this is not different. MA1 is same as ARMA 01. Why? Because we are setting P is equal to 0. That means ARP is 0. The thing remaining is MA1. And similarly, AR1 is ARMA 10. So this is just a matter of nomenclature. And what next? Suppose if a difference was taken in step 1. So remember, you are performing step 2 here. Step 1 was there before step 2, where you were using stationarity, you were checking stationarity, and you perhaps did some differentiation. So d is equal to 0, d is equal to 1, d is equal to 2, in order to establish the stationarity. Remember, in step 1 we already discussed. So suppose you have performed a stationarity adjustment by taking the difference, d is equal to 1. You know that. So then what we will do is, if from these observations we find that it is an MA1, then we will convert it to ARIMA. Why ARIMA? Because now we know that in step 1 we have taken d is equal to 1. That means first order of difference. So it cannot be ARMA right now. It has to be converted to ARIMA because there is a differentiation. So this ARMA 01, that means MA1, is to be converted to ARIMA 011. Why the center one? This is the d is equal to 1. See, if you will be confused if you are not seeing the video that comes before this. That means part 1 video. So I'm again suggesting you just go back to that video and complete the content. So because we have discussed all these things in that video. If you are not watching that video and just jumping onto this video, then you will be confused forever. So it is better to watch that video. I will provide the link here. That is not the point. The point is you have to complete all the 3 videos of ARIMA together in order to understand this very well. So similarly, again, you have if you have taken the difference in first step 1, then in step 2 you are finding AR1 model is a good fit, then you cannot take AR1 or ARMA 10. You have to take ARIMA 110. Why 110? Because in ARIMA is PDQ. The nomenclature is PDQ, and the center, that means the D is equal to 1 in your case because you have taken the first order of difference. And if it is ARMA 11, then it will be ARIMA 111, like that. So the point I was trying to make here is, if you have taken the difference in step 1, so please note that you have to convert the MA1 AR1 or say MAP ARQ or ARMA PQ models to ARIMA. You cannot take the ARMA models or AR model or MA models if you have taken the difference. So that was your step 2. Now in step 3, just you have to enter the data. How to enter the data? It is simply we will use the Minitab. In case of ARIMA, we are going to use the Minitab software, statistical software. In Minitab, we just to enter the data. That means in using step 2 and step 1, if you have concluded that it is a autoregressive model or moving average model or whatever model, then you have to enter values here. So for example in step 2, for example in step 1, you have find there is a difference of d is equal to 1, then you will enter d is equal to 1 here. In step 2, you have found that MA1 model is a good fit for this case, so you will enter 1 here and 0 here. Suppose in step 2 you have found that ARMA 11 is a better model in this case, so you will enter 1 here, 1 here. Suppose in step 1 you have found the differentiation was not necessary, that means d is equal to 0, so that means you will enter 0 here, like that. Just you have to enter 100 or 001 or 111 or whatever 121 in these 3 boxes, and your data will be somewhere here. Just you have to enter the data in series here. Okay, then you click on OK, and the report comes out. The report is in this form. This is the report, and this is the step 3. In step 4, we will see how to interpret the report. So this is your step 4. So how to interpret the report? First of all, you will go for the residual plots, which I have not shown here because I don't have any data here. How can I show? Just remember that you have to take out the residual plot and check for normality of the residual plot and the time sequence plot. What is the time sequence plot? That means along with the time, we will plot the residuals and see this, whether the data is stationary or not. That means the residuals itself themselves should not form any trend like that. So it should be flat with respect to time. So that is the first check, and also the normality check. What is the next one? Next one is the residual autocorrelation should be within plus minus 2 divided by square root of n. This is the second check. These 2 checks you cannot perform using this report. You have to take the residual report for residual graph for that. Then the third one is the p-value corresponding to the slope. What is the slope? This is the regression line. and this is the slope. This is the slope coefficient, and the p-value next to the slope coefficient should be less than or equal to less than 0.05 in order to make this model significant. So there are two aspects. The first aspect is significance, and the second aspect is adequacy. So for the significance, you will check this p-value. And what is adequacy? Adequacy is the next step, fourth, in which you will find this Q statistics. This is called the Young box chi-square statistic, whatever it is. So you will check these p-values. All these p-values should be greater than 0.05. If they are greater than 0.05, then the overall model is adequate. So these four checks are there. Once you take out the report, you make sure that you check these four uh, points, and based on that you select your model. So for example, you have selected MA1. For example, you have selected MA1 and you found that it is significant but not adequate. Then you cannot use MA1. Then go for some other model, maybe MA2 or AR1, whatever is the next best. You check for that. But what will happen if you found that there are more than one models that are significant also and adequate also? So for that, you consider this MS value. So suppose you are finding that MA1 and AR1 are both significant also and adequate also. So what we will do is we will take that one for which the MS value is minimum. So that is one method of breaking the tie. So in this way we will break the tie or check the significance and adequacy of the model. So this completes the discussion of step 1, step 2, step 3 and step 4. And for the future forecast also, basically all these things we are doing for forecasting the future data. So you don't have to do anything, the software will do it for you. You just have to specify the number of periods, that means the period ahead forecast that you want, and the software will make that for you. So this is the complete discussion for step 1, step 2, step 3 and step 4. I hope that you have understood this. Even if you have not understood this will create a foundation, solid foundation for the next video, in which we will discuss how to implement these 4 steps for real data. And then if something is not clear in this video, that will be taken care of and those will be clear also in that. Until then, goodbye and thanks for watching this video.